So now we want to continue looking at moving these graphs around. This time we're going to be talking about what's actually going to be a horizontal shift. It's written right now as f of x minus c, and you'll see as we look at some examples in a moment here why we write it as minus c. But some examples of what we mean with horizontal shifts. The number that's been adjusted to the function is put inside the operation. What I mean by that is, you see here we have x minus 3 quantity squared. The minus 3 is inside the squaring operation. Or x plus 2, it's inside the absolute value operation. Or x plus 5, the plus 5 is inside the square root. Or the 1 over x minus 4 is in the denominator along with the x. That's in contrast to the vertical shifts that we looked at earlier, where it's outside of the actual function, where it's outside the actual operation. So let's consider some examples. Again, you should have found a link for this interactive graph so that you can go in and also work with it. But here we have it written in the format x plus a squared. And I want you to see what effect that has now as we change a. Right now a is set to 0. A is set to 0, so it's really just the x squared graph. But notice when a gets bigger, if I move it up to a, watch the graph. As I move that up to 1, x plus 1 actually caused the graph to move to the left 1 unit, kind of counter to what you'd expect. And that's the same for any value here. If I make it bigger, x plus 2 actually makes it go 2 units to the left. X plus 4 makes it go 4 units to the left. Notice now when x is negative, though, which would really mean x minus 2, it actually goes 2 units to the right. And the same thing with minus 4. So that's why back here I write it as minus c. If it's minus c, it'll actually go c units to the right. If it's plus c, it'll actually go c units to the left. Now that was the graph of x squared. We can do the same thing if you scroll down, and I really encourage you to do this on your own. Look at the absolute value graph. Again, positive numbers, adding something on, causes it to move to the left that far. So there it's going 2 to the left. Whereas negative numbers cause it to go to the left, or to the right, sorry. So subtracting actually moves it to the right, adding moves it to the right, or left. Again, counterintuitive to what you would naturally think. And you see that this is the same with the square root graph. Adding plus 2 makes the graph go 2 to the left. Subtracting 4 makes the graph go 4 to the right. And finally, with 1 over x, as I move this to the right, or add on a plus 1, notice that graph shifts 1 unit, so that the vertical line that it's approaching now is actually x equals negative 1. And likewise, if I make it minus 2 there, the vertical line it's approaching now is right here at x equals 2. So it's again also shifting the graph to the left and right. And as you play around with these, you can actually let them kind of automatically go if you want a fancy little picture here. And you can see that when it's positive, it's to the left. When it's negative, no matter where I stop, it's moving the graph that many units to the right. Okay, so that's our vertical shift. Or sorry, our vertical shift. That's our horizontal shift. And so if we look at our 4 examples here, the minus 3, x minus 3, would cause the x squared graph, the U-shaped graph, to go 3 to the right. The x plus 2 on the absolute value would cause that V-shaped graph to go 2 to the left. The x plus 5 in the square root would cause that graph to go 5 units to the left. And finally, the minus 4 in the 1 over x function would cause it to move 4 units to the right. So 3 units to the right for x squared, 2 units to the left for absolute value, 5 units to the left for the square root graph, and then finally 4 units to the right for the 1 over x graph. Okay, so in the upcoming videos, we will actually look at some actual graphs now and graphing them. Hopefully this kind of helps you as you explore, start to graph these functions.